the first hardware project I ever worked on was back in 2011. I was interested in making a self-documenting construction kit. So the idea behind this kit was that how can we integrate documentation into the design process? So as you're building something, it just constructs the documentation for you. So it consisted of these modular pieces that you connect together. And it was the first time I'd ever designed PCBs, and I guess I gave myself the added challenge of designing PCBs that were really weirdly shaped, because I wanted them to have a more organic form factor. I wanted the pieces to make something more interesting when they were connected together. So it consisted of 2 different boards, and at the time, I basically designed the form factor in SolidWorks. It was before I worked for Autodesk, so I guess I could say that. So I made it in SolidWorks, I shelled out the design, and then I figured out what the outline, the board outline I needed was. And basically, I looked online and I found that someone created a ULP. A ULP is a user language program. It's essentially like a program that you can share and run in Eagle to do lots of different things. So for example, you can use a ULP to create a bill of materials. But this particular ULP was to take DXFs that you might export from an application like Illustrator and then import it into Eagle so you can get your board outline and use a graphics software that's a lot more kind of capabilities for designing more organic shapes. So this was a ULP that was called Import Dxf Polygons. So I ended up using this ULP and imported my DXF from SolidWorks, and then I designed my board around that. But it was a really tedious process, because every time I wanted to make a change to my CAD file, I had to essentially rerun this ULP, re-import, reroute my board, and it was not the most ideal process. So I worked on this project for a few months, and then I kind of moved on to other things. But at the time I was working on it, I presented it at a conference, and then years later, a friend actually reached out to me, and she said she was writing this book on building open source hardware. And she remembered my project. She asked me if I wanted to write a guide on how to make weird shaped PCBs. And I was like, yeah, sure. So I basically wrote a chapter on modifying the shape of Arduino, and it was really about how to design PCBs that were not rectangular, especially in the context of fitting that PCB into a custom shape enclosure. So fast forward a few years, I had graduated from the Media Lab, and I was doing a short-term fellowship, and I saw this listing for a lead UX position at Autodesk, and it was for Tinkercad, 123D circuits, and Eagle. And I spoke to Matt, who's the director of Eagle, and basically he pitched this position as a way to basically make the exact problem I was trying to solve better for everyone as mechanical designers, as electrical designers that are building integrated products. So I got the job, and now I work at Autodesk. I've been there for a little bit over a year now, and I work on bridging Eagle with Fusion 360, which is our CAD tool, cloud-based CAD tool. And I also work on Tinkercad, and what I do there is introduce electronics to absolute beginners. So we took a lot of the features that existed on this product that was called Circuits.io. You might have used it before, but it's essentially a web-based electronic simulator. So you can breadboard and test electronics completely in the browser without having to purchase any components. And so we brought this over to Tinkercad, but really thought about how to make this more accessible to new audiences. So we did things like add visual programming. So rather than having to write your Arduino code in text, you could actually use Scratch-like blocks, and it'll generate the text Arduino code for you so that you can upload it in the Arduino IDE. But in terms of bridging together mechanical and electrical design, what I've been doing for Tinkercad is enabling people to integrate these little electronic modules that let you bring your design to life. So for example, if you want to make your design light up or move around with a vibration motor or swing its arms using a geared DC motor, you can do these using these electronic modules called circuit assemblies. But what I'm going to talk about today is the work that we do on Eagle. And if you don't know Eagle, it actually is an acronym. It stands for Easily Accessible Graphical Layout Editor. It's actually a 30-year-old product, but it was acquired by Autodesk in 2016. And one of the biggest efforts I've been able to contribute to is this feature that we introduced earlier this year called Fusion Sync. And essentially what it lets you do is work between Fusion 360 and Eagle so that you can generate 3D PCBs and really work across those workflows so that you can modify your PCB in context of your 3D design and reroute your board accordingly. So I'm going to talk about UX decisions that went into creating this feature. But before I want to get into that, I want to clarify what exactly I do as a UX designer. Is anyone here a UX designer? Okay, no one. So I think depending on what company you're in, or even just what group you're in within a company, UX can mean really different things. But what I do is kind of a combination of user interface design, interaction design, and user research. So basically designing the most logical and efficient workflows for people that are building with electronics. And one of the first things I actually worked on was for Eagle 8.0, which we launched last year. I basically redesigned 40 of the most egregiously bad icons for Eagle. So does anyone want to guess what this icon represents?
This is an old icon, right?
This is an older icon.
So we can make fun of it.
Yeah, you can make fun of it. I won't be offended.
The solar system?
Solar system, okay. Okay, so this is actually paste, right? Okay, anyone want to guess what these two are? These two are related to one another. Oh, yeah, actually someone got it. Yes, exactly. So those are electrical rule check and design rule check. Those are essentially to check for errors on your schematic or your board. And the last one, these are also related. Gate within a chip, gate swapping. Those are good guesses. So there are two different editors in Eagle, schematic and board, and those are the buttons you actually press to switch between those two editors. So it was really just going through redesigning about 40 icons. A lot of them were really small modifications just to improve the contrast, make them more legible in the application. But we launched Eagle 8.0 with these new icons, and really shortly afterward, we saw this forum post. So someone said, I'm trying out Eagle 8.0. The first thing I noticed is the icons, they're new. And I don't see a way to change it back to the classic style. So actually what this person is referring to is up until Eagle 8.0, we had this option for someone to switch back to the classic icons. So you could actually say, I don't want to look at the new icons. I want to go back. I want to revert back to these classic icons. And I just want to point out, in classic, two sticky figures side by side is copy, which I think is pretty amazing. Okay, so it wasn't just a single request. We got a few responses about this, and someone, said, after 15 years of using your software, I know where I need to go to use these icons, so when you change them, it's a really big deal for me. And someone wrote this really impassioned post informing us of every basically every UX request this person had. And I'm gonna highlight just one of them that I really love. So he said, why don't we have skins? Winamp 95 has skins, and it was really essential to my existence, so you should have skins. So I guess what this really taught me in going through this process was, I guess it was in some ways a rude awakening, because I realized, we have this responsibility. We have people that have been using this product for potentially decades, and they have a very particular way of using it. We take their requests really seriously. But we also know that we want to build the customer base for Eagle, and a lot of people that are using the software for the first time aren't going to know that a yellow dot is paste, and they're not going to be the ones posting on the forum either. And I think from like a design perspective, more generally, our team is really interested in moving the product forward and modernizing the UI. So we're not really afraid to make changes if we feel they're really justified. And I guess, long story short, we didn't add the feature back, so you can switch back to the classic view. And I haven't heard any complaints about it, so I think it's fine. Anyway, that's just to give you some context. We're working on a piece of software that's 30 years old. And so there's a lot of things that we have to think about and we have to be really careful about. essentially making it so that's still legacy compatible, but also not being afraid of making changes and helping to progress it forward. So I want to go back to what the main topic of this talk is, and that's the Fusion Sync feature. So we started this feature by really examining how people typically approach the process of designing enclosures for PCBs. And I guess as a product designer, I really had a general sense of how physical constraints often drive the design of a PCB. I did a quick sanity check, posted a poll on the PCB subreddit, just asking people, how do you usually start? Do you start with an enclosure and design your PCB around that enclosure, or do you start with a PCB and design your enclosure around the PCB? And it's pretty overwhelmingly in the first category. That kind of made sense to me. And I guess the way I think about it is that enclosures really affect what size component you use and where you place them on your board. And also, the general shape of your enclosure affects your board outline. This is, I think, a PCB that goes in a Furby's ear. So physical components and the board outline are what we really need to generate a 3D PCB for Fusion. So I'm going to talk about each of these in turn. So for components, in Eagle, components are really defined at the library level. So even before we started working on the Fusion Sync feature, we really wanted to create the infrastructure that made it easier for people to discover libraries that were created by third parties. So a lot of the really great libraries that were created for Eagle are created by people like SparkFun and Adafruit that are making it as easy as possible for people to build off their designs and incorporate their boards into new custom creations. So we created a feature called Manage Libraries. It's this little book shelf icon, but what that lets you do is you can essentially view all the shared libraries by right now just several of the content creators like SparkFun, Adafruit, and Seed in the application, but we're working towards growing this and also making it so that you can publicly share your assets with other people. So we basically created this managed library system, and this managed library system gives you access to our web portion of the Eagle product, which is called Circuits.io, and there you can import an Eagle library or open one that you've created as a managed library from within Eagle. And basically, for every footprint in your Eagle library, we generate a 3D package. And Chris actually did some fantastic work on that, as one of our developers here. So essentially, you can open up any of these packages, and what you'll be able to do is actually upload a step model, and then start to associate the relationship between the footprint and the 3D model. So this is kind of how the 3D model part of components starts to fit into how we think about libraries in Eagle. So when we first kind of introduced this, this feature in Eagle 8.3, we ended up getting this forum request where someone said that they weren't able to see their 3D models in Fusion. So they had uploaded the 3D models to our package editor, but they weren't seeing those changes in Fusion. And what turned out to be the problem is that essentially the way we set up our publishing system on Circuits.io is that we're really careful about versioning. So right now, essentially you can view your own managed libraries, and you can view managed libraries that were shared by content creators. But if you're actually editing them, you can only view your own right now. But ultimately, where we want to go is make it as easy as possible for you to be able to find libraries created by anyone. And at that point, versioning is going to be really important, because we want to make sure if you're sharing assets with lots of different people, you want to be able to explicitly say, okay, it's ready to share it with everyone. So essentially what we have is a versioning system where when you make changes, we actually have you create a new version. And what the problem was that in our library editor, there's this little thing in the top left or right for you guys that says save version plus changes. And that wasn't very visible, admittedly. And there's this little drop down here too to let you know that that's what you want to click to save a new version. But yeah, definitely wasn't visible enough. So this is just an example of how visual UI can really affect user experience. So what we ended up doing was we realized what people cared about was whether it was versioned or it was in a draft state. They didn't care if it was on version 1 plus changes or version 2 plus changes. They just cared about whether or not they need to save a version at all. So what we did is we changed it so that the version or the draft state is in a button container, so that looks more like something you can click than something like that. And we also changed the color background to let you know, okay, it's red, so it's draft state, maybe you should try to save a new version now. So these are just really small UI tweaks, and I think oftentimes something as small as that can really make a difference in terms of mitigating errors in user workflows. So this is what it looks like now. So if I uploaded a new package, I would save a new version of the package that I am working on, and then my library can fetch those latest updates and then publish a new version of my library. And I can explicitly define when I want to save the new version of my library whenever I feel it's in a state that's ready to share. So you'll see, once it's saved, it's no longer in draft state. So yeah, really small changes can help clarify the intended workflow to users. Okay, so we talked a bit about components. So the next thing was, how do you actually share the board outline? Because we need to know the shape of the board when we're bringing it to Fusion. So actually, typically, what people would do when they're defining a board outline is to draw the shape of the board on the dimension layer in Eagle, which is layer 20. But actually, there was no data associated with the lines drawn on that layer. It was just information about the board outline that you could draw essentially on any layer, but we needed to be really consistent about where that information was stored once we started to share that information with Fusion. So basically what we did is, this is actually far more interesting from a technical standpoint, I guess, than a UI standpoint, but now when you actually draw your board outline in Eagle in the dimension layer, you'll actually see visually, once it detects a closed contour, it'll change the color of the board to let you know, okay, this is the board outline we've detected, and then the editor background is a different color to sort of improve the contrast. So that was really important as another step to help generate a 3D PCB. So there's actually 2 workflows to do this. The first is to, you might, for example, want to design an enclosure for a custom PCB. Or you might want to design an enclosure for an off-the-shelf PCB. So for example, you might have something like an Arduino or a Raspberry Pi. You're probably not going to modify the electronics design, but you might want to bring a 3D version of it into Fusion and design something around it. And it turns out that Eagle or a Fusion actually treats these 2 cases as very different cases from a data perspective. So from kind of the UX side of things, we had to kind of outline exactly what the workflow is, exactly what's happening at each state of this particular process. So I'll show you what this looks like in Fusion now. So in the first case, we're designing a enclosure around a custom PCB. So you actually start from Fusion, and I've already designed some enclosure, and then I can define my board outline, taking into account any standoffs or anything that I need to incorporate, and then I create a PCB feature. And then what you do is, once you've created that feature, you can associate your Eagle design with that particular feature. So if I switch back to Eagle, I can open up this Fusion Sync feature and say I want to link to an existing design, select that feature that I just created, and then it will bring in the board outline that I just defined in Fusion. So this process is really designed for a very custom PCB where you want to be able to iteratively work back and forth between Fusion and Eagle. So you may discover, for example, that you have a component that needs to move. You have a component that needs to move because it's interfering with your enclosure. So what this lets you do is really start to move components, redefine your board outline, and work really iteratively between the 2 applications. But the second process that I mentioned to you, where you're designing the enclosure around kind of a fixed PCB, is treated really differently in Fusion. And the way it's treated is, it's treated as an XREF. So an XREF is essentially a part that you're including in a design, and an XREF is kind of like an external reference to a part. So this is an example of one of the circuit assemblies I really briefly mentioned earlier for Tinkercad. So it uses a geared motor, and it's an off-the-shelf component, so I'm not going to change anything about it. But it's actually inserted in this assembly as an XREF, and if I want to edit it, I actually have to open it in a completely different workspace. And this is just really a technical limitation that XREFs can't be edited in place, but that takes away a lot of the functionality that we're trying to encourage, that you want to kind of work back and forth. But you know, in the case where you're working with a fixed PCB, it doesn't really matter. So you know, with the XREF, you could insert it into multiple designs. So there's kind of like trade-offs and pros and cons to these two approaches. So on the Eagle side of things, what that would look like is I have this particular design. I can open up Fusion Sync and say that I want to actually create a new design rather than reference an existing PCB feature. And then what it'll do is it'll generate a completely new Fusion design. So if I go to Fusion, it created my PCB. And then that PCB can actually be used as an XREF to lots of different designs. So it's not tied to a single design. I can have lots of different designs that use this PCB, but I can't edit it in place. That's really solely a technical limitation of XREFs, I guess. So what we did in the process from a UX UI perspective is that the first step of the Fusion Sync workflow makes the user basically make a very explicit choice between the two options. So you have the option to either link to an existing Fusion design or create a new Fusion design. And actually, there was a lot of thought that went into the wording of this. And I think what I often find in a lot of UI design is that people tend to eliminate a lot of the kind of wording or captions that you might provide to give more context for the sake of eliminating visual clutter. But I think in this case, you know, what the implications of linking to an existing PCB or creating a new Fusion design are kind of important. So, you know, linking to an existing design lets you iteratively edit the PCB in the context of a single Fusion design. So you can't put it in multiple. But if you create a new design, you can put it into multiple Fusion models. But what you're really doing is creating a mechanical model to fit around your PCB. So I guess the reason I'm highlighting this is sometimes I think being really descriptive and explicit can help just clarify exactly what the decision the user is making at that particular point. And especially when you're talking about something like fairly technical, I think it's helpful to include it, even if it adds a little bit more text to the UI. Okay, so there are other parts of this process, like, for example, how to let people know if there are changes that you should pull from Eagle or pull from Fusion, or if there are changes that you've made in Eagle that are not represented on the Fusion side that you should push. So there's a whole kind of process that went into thinking about that I'm not going to talk about today. But what I wanted to mention really quickly is that I think what kind of a positive side effect of all of this is that new features have really trickled down into improving Eagle UI more generally. So as an example, we want to make it really clear to users when they're looking at their libraries, which components in their libraries actually have 3D models associated with them. So we added a preview pane to the library editor, and that's really useful regardless of whether you have 3D models or not. So in the past, what you would have to do is actually double click any of them to view what they look like. So I think in the process of working on these new features, we've been able to improve other parts of the Eagle user experience. So if you want to try this out, you actually don't have to do anything in Eagle. I mean, you download the latest version of Eagle, but Fusion Sync is by default available, so you can try it out. If you use Fusion, you will actually have to enable the PCB feature. So you go into preferences in Fusion, click on preview, and then you could activate the PCB feature and try it out yourselves. And I'd love to hear feedback if you have any on it. I also want to give you a quick preview of some stuff that we're working on for the new year. So what we're going to actually enable you to do is generate packages, so footprints and 3D models, directly from the data that you already have in a data sheet. So this is an example of just generating a CQFP package, and I can iteratively say, okay, I'm going to change the number of pins, and it'll generate a new package for me. So much faster way to generate 3D models and footprints than we currently have in Eagle or Fusion. And Yeah, I guess I wanted to end by saying that I think Fusion Sync is still beta, but I think it's a really critical first step towards addressing a lot of the challenges I mentioned at the beginning of the presentation. And in Fusion, you can really dimension board shapes in a very parametric way that lets you define a lot of relationships and constraints, and actually then bring that board into Eagle. And kind of in a very timely manner, I saw this tweet from Todd, who wrote the import Dxf script that I had used, and he said it was time to retire it. Now that we have this feature. So I'm really excited. If I had this 6 years ago, it really would have made a difference to me. So I hope it makes a difference to you guys. I'm really excited to continue making it the best feature it can be. So you can follow us at ADSK Eagle on Twitter for the latest news, features, and events. Thanks so much for your time.